Right, going live. Should be going live in a second. All right, we are live. So what's going on, everybody? Welcome to the Turbo Makes Games YouTube channel. I'm Johnny, and I'm joined with Tobias here today. How are you doing today?
I'm doing great. Thank you.
Awesome. Yeah,
Yeah.
thanks for joining me. So yeah, Tobias is a game developer. He's working on a game created with Unity Dots right now, and so we're here to just kind of talk about his experience with developing it and just kind of give you a little overview about his game. So actually, can you just give us a quick little overview about what your game is, and what it's called, what it's all about?
Yeah, sure. So it's called Just Read the Instructions. It's a co-op first-person shooter, PvE style. So it's sort of it draws a lot of inspiration from Left 4 Dead and Deep Rock Galactic and Vermintide and those type of co-op co-op games. Uh, and we are using dots to cram as many enemies as possible into the game at the same time. So that's sort of the nice gimmick that ties into the dots thing, and that makes our game quite unique. Um, Otherwise, it's kind of a straightforward shooter in some sense, but with a lot of enemies and with a lot of strange instructions. So we usually say that if you aren't squinting at the instructions, you're probably not real. It's like what is supposed to be. Yeah, that's what the feeling we are trying to strive for. That you're like always like, what the hell are we supposed to do?
Awesome.
And couple that with a lot of enemies, I think it's a pretty sweet deal.
Great, awesome. Yeah, just give people a quick kind of like visual reference of what the game looks like. I'm just going to go ahead and kind of show off the trailer here. So we'll switch over to this, and we can kind of go ahead and just play through this here. So you did say this trailer is a little bit outdated. So about how long have you has your team been working on this game for now?
Me and my we've been working for a little over a year. Well, primarily 2 years. I mean, so 2 years, like proper production. Maybe a little bit longer with pre stuff, but it takes a long time. But we are only two people, so yeah, 2 years.
Nice. Yeah, so we're playing it now, and we kind of have some nice shots of like inside of a hallway, and there's like a bunch of these kind of like polygonal enemies going around.
Yeah.
Um, so yeah, and yeah, I mean, there's just all kinds of craziness going on. I see. I mean, really fun looking game.
Yeah, like you say, it's a little bit outdated, this particular trailer in terms of like your equipment and stuff. But otherwise, it's mostly like it's the same. Exactly what you're seeing is what we're trying to achieve and everything. Like with all the crawlers, and the enemies are called crawlers, and how they attack you and how they move and everything. That's precisely how it is today as well. So that's the main thing. So it's a representative. My mouth is not doing what I want there. Yeah, but it looks like it should in that sense, and yeah.
Yeah, no, that's
Uh,
awesome. I think it's a really cool looking game. Also, I love the name. Just read the instructions.
yeah, it's if there's anybody who's like a SpaceX fans, we actually took it from one of their drone ships that catches the boosters out in the
Oh,
sea.
okay,
It's
okay.
one of them is called Just Read Instructions. It's not like it has anything to do with them. It's just we thought it was a fun name, and that's
Yeah,
where
yeah,
it
yeah,
comes
yeah,
from.
yeah. Nice.
Yeah,
Yeah. No, I've heard that name from that before.
yeah.
So tell us a little bit about some of these instructions. I think that sounded like kind of an interesting thing when you're going over the pitch. Like what are you kind of like instructing players to do?
Yeah, so like I said, we want to have the experience of like having to squint at the like, what are we supposed to do? Because we're trying to achieve something that doesn't feel like the typical. Because in essence, it's just like a quest system, right? And it's hard to not be if you are supposed to instruct players about doing stuff.
Right.
But we want to like squarely get out of the game normal game quest zone and do stuff that is just ridiculously weird and stupid. So, for example, to spoil one of them that we're working on is like sell Girl Scout cookies. Like, what is that supposed to mean? And like, then you find these houses and you open and you um, you're greeted by this robotic weird thing that's like a suburban mom or something, and she's like, oh, um, we aren't trying to make it convincing and or realistic in any way, shape, or form. We're just trying to like,
Yeah, yeah,
this is just a weird thing to do in an FPS, and that tension between those things about doing weird stuff and then turning around and seeing like thousands of crawlers behind you and having to deal with that. That's a contrast we are exploring.
yeah. No, that's awesome. I think it's like a very like abstract looking game, and it's cool that you guys are kind of like leaning into that with the story aspects and just kind of like asking the players to do just like wacky, weird, ridiculous
Yeah,
things.
exactly. It's like surreal and a bit abstract and just strange. And we feel I don't remember any like game that in a multiplayer sense that does that type of thing. So we feel we have a niche thing that's quite interesting there.
Yeah, yeah, totally. So, where did kind of the idea come from? You mentioned that you're kind of like a two-person studio. So, how did this kind of like partnership between you and the other developer like come about? And like, kind of talk about the origins of your studio a little bit and how you guys came to the idea of this game.
Yeah, sure. So just to like, I have worked as a game developer at a company called Stunlock Studios on a game called Battle Rights for about 6 years prior, and I was getting, I want to do something myself, and I was working on this uh, VR tower defense. And I asked my friend, who an old colleague, like he started talking about this dots thing. This was 2 years ago, a bit over 2 years ago, and I was asking him about how do you think this could like aid us in putting more enemies into the tower defense game that I made on my spare time. And he was like, "Yeah, sure. I think we can. You could probably like squeeze in like 40,000 of them." And Jesus Christ, that's not necessary. I thought. But then I started experimenting and developed some sort of a proof of concept. And yeah, 40,000 was a pretty reasonable number. And at the same time, I got to like I regained some contact with an old university friend of mine, and we started talking about this. And I was tired of working at this place where they are an awesome studio, but just I want to do my own thing.
Yeah, yeah,
And
totally.
yeah, and me and my friends sort of put one together, and like we should maybe start a studio together. And at the same time, we sort of realized that and see tower defense VR is sort of a niche thing, and it's hard to really get a good audience with it. So I just plucked down a first-person controller into the scene with all these enemies, and I was like, "This is really fun to just go
you're
around
like you're
shooting
like
these
there's
things."
something here. Yeah.
Yeah, and then I Battle Right is a PvP. The game that I worked on before is a PvP game, and we sort of shipped it with a replay feature where you can like scrutinize every moment of the game in after you played it and like watch all potential latency related issues unfold before you. And like gamers hate that kind of unfairness, it's
Yeah, yeah,
but it's
yeah.
like it's impossible to make that stuff work properly on the network because latency is a thing. So I had sort of a distaste for PvP because of fairness. So I was like, I think a cooperative game where one of the players is the server, and so we don't have to pay for server costs and stuff like that. Uh, that's sort of a sweet spot between utilizing multiplayer social dynamics that drive people to play and have fun together, but not having it PvP. So fairness is not a thing. Uh, that's a super sweet spot. So we married that idea with the thing that dots allow so many enemies and it's really fun to shoot these guys. And that's sort of how this genre combination came to be. So it was a lot of technical reasons, but also it just sounded fun.
Gotcha. Yeah. So it kind of sounds like you guys sort of had this idea of like just like fighting a bunch of enemies and stuff like that. And then sort of the idea for this game kind of evolved out of that.
Yeah, yeah, and we both are huge fans of like Left 4 Dead and stuff like that, and actually, I don't know if this is something, because I'm not that knowledgeable about all the games that comes out, but I feel like this, since Left 4 Dead, there's like been almost way fewer games that do the same thing than you would expect. Like, there's so many genre combinations. It's like flooded on Steam, and it's really hard to
Right. Yeah.
get through the buzz. But if you search for like first person co-op games, it's not that much. So that's also like, it's so nice to be huge fans of a genre and then realize like, yeah, this is a proper, we can do this. This is, so people are asking for this. This is a popular thing. So that was very much match made in heaven for us to be able to do that and feel like we were making something competitive and not just like another one in the pile of games.
Yeah.
So,
yeah. And so kind of to talk about, I guess sort of how like the idea of this, like just read the instructions kind of quirk mechanic came about. How did that kind of get involved? Like you sort of had this idea for this game where, you wanted to be fighting a bunch of enemies. Like how did it kind of evolve into this kind of like quirky, weird, silly thing that you have now?
yeah, it's hard almost to like figure it out myself. I've thought about it a lot, like how did we end up here?
It's
And
just, was it just kind of one of those slow things where you guys are just like kind of
it
just like,
was
oh,
really
this would be funny if this with that, and then you kind of got to this
yeah,
point.
it was really slow. It took, we like the name was actually set like a year ago, a little bit over a year ago, and we the name has informed a bit of the gameplay. So it's
Okay,
not like
interesting.
yeah, and but we view ourselves as a like highly agile two people. Like
Yeah, I mean,
we
you're a
really just
two-person
like
team.
throwaways.
Yeah, you can
Yeah,
have
we
the
can do.
flexibility to do that, and yeah,
Exactly. So we just followed the fun, like for the first year or something. We just like continue developing stuff that sounded fun,
that's a
and like
great term. Follow the fun. I like that.
yeah, yeah. So we just like, there's so many ideas that we talked about and it sounded fun, and then we like started on like trying out, and then it's just like stuff just falls to the wayside automatically if you allow it, and then you sort of like have this automatic just working on those things that engage you and makes you
Yeah,
want to play your own game more and stuff like that. And of course there's like tons of architectural stuff to do around the game that really doesn't really contribute more much to the current state of the game. You need to make everything work, and networking and all that stuff. So obviously I worked a ton of just like low level stuff, especially in dots, since it's so low level in some sense. But otherwise, we just like we implemented stuff and we tried, and we realized that sort of instructions in some way, or I guess it was quests or something from the beginning. It was easy to just like start in that corner and like, oh, let's just have questions, something to do, something to say the player like do this, and then we continued on this, and then all of a sudden like I said to Klaus, my colleague's name is Klaus, he likes long names. I knew that before since we studied together, and I said like, what about just read instructions? And he's like, yeah, I like that. That's a fun name. That's a weird name.
yeah,
And then it's sort of like, yeah, the idea and the name started building on top of each other, and we got some inspirations from other people, and some people this is fun because some people like hear the name and they pile on ideas to you that you hadn't even thought about just from the name, and like oh, so you're making a game where you do like this and this and that, and we're like,
they're
no,
like, oh
but
yeah, sure,
that's
that's a
pretty
good
fun.
idea. I like that.
Exactly, that actually happened a few times with the game.
That's great.
And it's not exactly what we're doing right now, but it informed us and like led us a little bit further down the path we are right now. So it's hard to pinpoint exactly where it happened because we were so fluid for the first 1.5 years almost. So yeah, but that's sort of how it came to be.
That's great. And then, so yeah, you kind of said that you were, a little bit more fluid towards the beginning. So do you feel like you're kind of on like a path right now where you have like a really solid understanding of what the game is and like the exact things that you need to do to finish it?
we are by far the most certain about the game yet. That's for sure. But it's still like um, we are planning like almost like we are aiming for like 40 instructions in the end, like
Okay.
distinct different instructions or something like that along those lines. And um, we don't know 40 different instructions right now, so it's obviously a long way to go. And there's a lot of map generation stuff to make and stuff that we are not really sure where it's going to go. But so for this fall, we want to release a demo that has like 3 maps or something, and for that, what that's supposed to be, that is almost nailed down. We know what we want to do with it. We might throw out some instruction if it doesn't turn out that well in practical terms, and swap for another one. But otherwise, the whole structure, the whole like production design, I think you can call it, that's nailed down, and we're just trying to find like the best combination of start puzzle pieces to let the player be engaged.
Nice. And then, so is this kind of a little bit more of like an open world type game, or are there like different levels that you're playing through? Like, what's kind of the structure of that?
So I don't think that tag is really showing in Steam, but we actually have procedurally generated maps.
Oh, okay, nice.
So it's structured. Think about like Super Mario or something, where you have a distinct set of stars that you need to take, right?
Yeah.
That's sort of how we view every single instruction. So you have like this set of instruction that is completely global fixed, and you select it, and with that instructions come a theme of a map. So like maybe a skyscraper city, and when you jump into that map with that instruction, you get a unique layout for that time you play it. So next time you play it, you will get another layout. It will look sort of the same textures, the same prefab, everything. It's a theme. But every time you play it, you will get a new layout, either you want it or not. And that's sort of how to throw a wrench into and get more playability. So when you're really trying, like 15 minutes in or 20 minutes into a level, and you're like, we almost got this, then you know that if you fail, you're gonna have to retry, and you're gonna have a completely different layout to try it on. So and then sort of some sort of a progression thing where you can play with your friends on any map that that somebody have unlocked, and unlocking more and more instructions, or map and instruction in this case are sort of the same thing. An instruction come with a map, and that map has a new layout every time you try it. But that's, I don't know, it's hard to explain exactly, but it's focused around the instruction, and with the instruction comes a new layout and a map that and you need to progress through them with your friends.
Awesome. Yeah, that sounds awesome. I'm really excited to actually get my hands on and play this game a little bit. By the way, I did leave a link to the Steam page down in the description below, so you guys can go wishlist that, and you can hear more about it when it's ready to come and everything. So I kind of want to transition to talk a little bit more about the technical side. So I think kind of like an interesting place to start would just be kind of give us like your background a little bit about development. How did you kind of get into programming in general? Did you go to school for programming? Talk about kind of like how you started to learn programming and got involved with that.
I saw somebody using 3ds Max like 2005 or something.
Okay.
And I was like, holy shit, that's how you model stuff. I was so blown away by how to model a 3D model in a computer.
I was like totally the same way, like seeing like oh, like that's kind of like how it's made, like that's so cool.
Yeah, exactly. So I was completely spelled into just I don't know. I was really interested in it, and I decided to pirate 3DS to download it when I was 15 years old, and I tried to use it, and I had some fun. And after like a half a year or maybe a year of trying out modeling stuff, I realized I'm not artistic at all. I really suck at this. And
It's
then
hard, man.
and then it's like it progressed into I realized like, oh, next year I'm going to take some programming courses at my I don't know, when you're like 17 or above. I don't know what you call it in the States. We call it gymnasium in Swedish.
Gymnasium, okay.
Yeah, high school, I think it is. Yeah, it's high school. Anyway, I saw programming was on my course thing, and I was like, I want to jump into that before. So I just like I spent a week trying to code Snake, and I succeeded. And
Nice.
like actually, the rest is history. I never looked back. It was like completely like mind blown. This is what I want to do.
Awesome.
And then I realized that there were a university with the game development, just an hour away from where I grew up.
Okay.
And 2009, I went there and started my 3 years of university education in game programming.
Awesome.
So yeah, and it's a very famous, very I don't know, very famous, but it's a famous place. Have you heard about the Goat Simulator?
Yeah, of course.
Yeah, that's made by old friends at same
Okay.
school.
What's the school called?
Um, University of Skövde. It's
I'm not going to be able to
have a good
repeat that.
English name actually. Sorry, but it's in Skövde, so it's just the place, the town is called Skövde, and that's where most of it. That's how you sort of identify it. But obviously, it's not that famous since a lot of people, including you, haven't never heard about it. But there's a lot of cool games.
There
that
was
come from there.
a Swedish university. I talked to some people at GDC. They were there. They had a program. I forget what their college was though, or their university rather. It wasn't the one that you were referring to though.
Which game?
I
Or studio?
it was a university. I don't think
Oh,
they were basically
right,
just
right.
there like promoting their university. They weren't like showing off a project or anything like that. But yeah, I can't remember. This was a couple years ago. But yeah, they were,
It's
they were like
hard.
super cool people.
Yeah, nice, nice. Yeah, we have a few. We have like four, I think, different proper universities for game development, 4 or 5 or something like that. Yeah. Anyway, spent 4 years here. I still live in the same town, and then I did my thesis, bachelor degree. I don't know how to. The last half year of my education I did at
Mhm.
Stanlock Studios where I worked, and then I went straight into working for them. And spent 6 years there. So, and I've been like 100% focused on programming more or less for like, I don't know, 14 years of my life now.
Wow, that's
Uh,
awesome.
yeah, it's truly my passion, I think.
That's great. That's awesome that you found it. I know I love programming too. I mean, it's just like I wish I had more time for more programming. It's just,
But,
there's always like so many problems to figure out, and it's very
yeah,
rewarding.
it's like it, like problem solving in the most pure way, no distractions. It's so addictive. Yeah.
Yeah, that's great. And then, yeah, just to real quickly kind of touch on, I guess the game development scene over there in Sweden. Um, like, how would you kind of describe it? I guess.
We locally here in Skövde, it's actually like really, it's like one of the golden things about the city. I think we have something called a game incubator. It's like
Okay.
a place where you can go and get help with starting your own company and stuff. And that really like drives a lot of new students. Like people go straight from the university and try to make a game company. And A lot of them fail, but a lot of them succeed as well. And we have like really a vibrant whole community of a lot of people. Like Valheim, do you know about that game?
You said what? Oh yeah,
Valheim.
Valheim. Yeah.
Yeah, Valheim. Yeah, that's also made here in Skövde.
Okay.
Just
Wow.
like a few
Oh,
hundred
no
meters
kidding.
from where I sit, I think. Yeah, and I know a few of them like so. It's absolutely amazing to see that a small city in Sweden can get that kind of recognition, and there's so many talented people here.
Yeah,
So
that's super
that's
cool
super
that there's
fun.
kind of like the little pockets of little game development communities. I know I've done a couple of these like little live stream interviews with some other game developers. And the previous two that I did, both of the teams actually happen to be located in the Netherlands. So there's just kind of
Oh
like these these like little pockets of little game
yeah,
development communities just kind of spotted around the world. So I think that's super cool.
yeah. We have actually a bunch of people from Netherlands who have moved here to work on games at
Okay.
Coffee Stain Studios, the one who made Goat Simulator.
Yeah. 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 Yeah.
Yeah, they work there, and so it's super fun. And at Stanlock Studios, we had people from all around the world join us to like moved from LA over here to work on games in little Skövde in Sweden. That's super fun that people find it so interesting that they want to move here. So yeah, we have a really vibrant game dev community here. It's super
Nice.
fun.
Yeah, actually, I see someone in the chat saying Valheim, Raft, Satisfactory, Goat Simulator, and Battle
Battle
Right are
rights.
all made in. Is that how you spell it? Skovde.
Yeah. The O with the two dots is like
Ugh.
it's a weird Swedish. Yeah,
You say
yeah.
you
It's
say
good.
Skövde. Is that close?
Skövde. It's like with the SCH sound almost. Skövde.
Skövde.
Yeah, there you go. That's
Okay.
like perfect. Yeah. So good that he. I think I know who that is. That he like filled in the rest, like Satisfactory and Raft of all big successes as well. So it's nice to see that. Yeah, when you're sitting in this setting with a conversation like this, it's hard to. It's easy to forget
Yeah,
details like
totally. You're
that.
like, oh,
Yeah,
I totally forgot. Yeah.
yeah, exactly.
Cool. So yeah, kind of talking about a little bit more of your work experience. So just kind of briefly go over like what was your experience on that studio? What were you using to develop? Were you guys using Unity?
Yeah. So at Stanlock, we when I started there, we worked on a spin-off to Dead Island called Dead Island Epidemic,
Okay.
which never left beta, but it was a top-down fighting game, or like Battle Right is, but with also zombies, sort of. And I started with the work title of clean up after the designers, basically, because they were like aiming for results, and the engineer felt like, well, hang on a minute, we need to have some stability in the systems as well. So that was what I spent my first year there, like cleaning code and rewriting stuff, and then we started working on Battle Right, like I think 2015. And on Battlerite, I worked on the physics engine or engine. I mean, it's a pretty trivial thing, just a like physics solver, small thing in 2D. And I worked on the AI. I made like the whole bot architecture, which I'm really proud of. It was
Mm-hmm.
really fun, and also all the physical animations, like hair and stuff. Really fun to work on. And Battlerite is visually rendering wise completely made in Unity, but the whole gameplay system, everything is completely devoid from Unity.
Interesting.
It's a very clever and at that time at least very fitting way of making a game. Not Battle Right top down fighting game. It's like WoW Arena, but top down and just the arena and just fighting with spells basically, and WSD movement and mouse aiming. um, and that game requires so much balancing and stuff, so they focused from the beginning on making like the gameplay loop and not gameplay loop, the gameplay development loop as tight as possible. So there was basically like a divide. You had the gameplay engine, which was completely made by us, and then that like communicated into Unity and made Unity write stuff on the screen. And we could like Unity wasn't necessary, like didn't have to be as fast in development wise, because our own game tool with all the tools we made around that was like hot reloaded everything. You could make like a new character in the game from scratch without restarting the game session, because everything was so optimized for iterating. Yeah. So it's a very, very interesting concept that wasn't that performant in the end, but it was really, really fast to make that type of game in, and very, very proud of that.
Yeah,
Part of that.
that's a super interesting solution. You kind of have like a little bit of a proprietary engine using a little bit of Unity. So yeah, that's super interesting.
Yeah, and like I bet every single Unity programmer who have ever put a breakpoint and hooked up the debugger in Unity, like have had a I don't know, pull their hairs out once or twice because of just everything is hanging. It's the debugger into Visual Studio sucks in Unity, right?
Yeah,
Have you had
yeah.
the same experience? Yeah.
Yeah.
It's you have to hope for it not to get stuck when it's like super complicated stuff. We sidestep all of that because we had when you ran the game in like a release type mode, then it was the same process and everything, and the communication was just like you set struct on the Unity side and just like render this, have fun. But when in development mode, there was an HTTP, just like IP, not, what the other one, not IP, just like UDP connection.
Okay, yeah.
Just like and it was two separate executables. So you could have Unity running with the graphical stuff, and then you could have the game running in another executable with the logic. And since that was just pure Visual Studio, you could just breakpoint, and it worked like C# in Visual Studio works really fast and well. So that type of development cycle really it really made everything so much smoother.
So was that kind of like the main driving force behind doing that separation, is just kind of for like ease of development?
Yeah, 100%. Oh well, no, let me. It was. I realized there was another core part, and like the same reason why I worked on the physics engine, and we made all that from scratch. Like when you're making that type of a fair PvP game, you really need to have full control of all the gameplay mechanics and their execution order and stuff like that. So
you want it to all be deterministic and all that?
Well, not necessarily deterministic, but
predictable.
Being able to predictable in some sense, but also everything being able to be rolled back, right? So you can like roll back and re-simulate from a newly discovered package that like, oh, he actually pressed this button right here, like
right
100 milliseconds ago, and that's between the ranges of the accepted packet delays and stuff, and like, oh well, we need to re-simulate this because something else happened. And having that all from scratch written allowed the game to be really tightly integrated with the network engine, so the game was really fair. Actually, it was very well made in that sense. And I didn't have much to do with the network of the game, so but it was really
but it sounds like you kind of still got like a little bit of exposure to sort of the problems they were running into, so you kind of maybe prepared yourself a little bit for what you might be facing with in your own projects, which I'm sure we'll be talking about soon.
yeah, exactly. Oh, completely agree.
Awesome. Yeah, so then I guess kind of transitioning over to your own project that you're working on, Just Read the Instructions. So kind of what was your decision to go with Unity in the first place? Was it just because you sort of had like a little bit of experience with it already in some kind of sense with your development job? Or were there other kind of decisions that went into that?
I've been, apart from a small 2D game which wasn't Unity, and a skydiving game in university which was in Unreal Engine. Otherwise, everything basically I made in Unity since like 2012, I think, or maybe 2011 actually. So obviously, I have a huge amount of experience with Unity, and at Stunlock we made even though a lot of the gameplay was made in C# purely, I worked mostly in Unity with different integration stuff and animation stuff and stuff like that. So there was kind of it wasn't a no-brainer per se, but like when my colleagues showed me dots and I started exploring that, and I made some, I can talk about that later, made some experiments which like completely blew my mind. I didn't really even think about Unreal Engine or anything else. I was like, I think this is on the verge of doing something new, incredible, and like opening up performance in a completely different paradigm with Unity dots, and I want to be a part of it. And at that time, Unity had not rolled back a bit of their dots timeline, which they have done now. Now everything is way more hush hush and like super preview, and don't touch it if you don't know exactly what you're doing and stuff like that. Back then it was much more like, oh, just like press in this preview thing and go have fun.
Right.
Yeah, so that was very much easy choice to make that type of game in Unity, and maybe we'll turn to Unreal once in the future. But right now, I'm very happy with Unity, and it's sort of the gameplay idea is fueled by the tech that we can use in dots. So it's not like we can switch for fun if we wanted to.
Yeah. Nice. So yeah, it sounds like you're kind of like blown away by your experience just experimenting with dots a little bit. So do you remember kind of some of the things that you were doing, or were you just like trying to see like how many things you could stuff into a scene and just see what it takes to make your computer melt?
Yeah. I have two really good examples, which is maybe I can link to one of them. I think I post one of them to the Unity subreddit once. Anyway, so in Battlerite we had Verlet integrated stuff. Do you know what I talk about? Have you worked with Verlet integration and constraints?
No.
Then I should talk about that later maybe. But yeah, it's fun. It's a fun thing. It's basically in all cloth made basically in all both real time and non real time is made with Verlet integrated stuff and constraints. It's a very interesting physics paradigm, so to speak. And I made the palms, like the trees in the game in Battlerite, and they like swing when you hit something, and they very naturally work well and look very good, and it was really good feeling in just that little aspect.
Is that similar to kind of like an inverse kinematics at all?
No, it doesn't really have. It's just like when you do position plus delta times velocity.
Okay.
That's usually called an Euler integration.
Right.
This is a completely different integration method where you instead keep track of your past frames position and your current position.
Okay.
And then you use that to integrate into to go one step further in the simulation.
I see what you mean.
It's easier in practice than it sounds when you get when I'm not that good with mathematics, so I was completely lost when I heard about it first time. But it's really fun and easy when you learn about it. Anyway, it's the best way to use to simulate secondary animations, like stuff that doesn't have any impact on the gameplay. So in Battlerite we had a lot of those things, hair and the palms, and a lot of fun thing which moved with stuff just for visual flair. And I remember like putting like 20 palms in the game, and I could already see them in the profiler. Like, we're spending a bunch of time on simulating my damn palms. Maybe we shouldn't have 20 of them. So we had like I think 4 in the biggest map or something. And then I re-implemented very naive implementation in dots, and I got like 10,000 at the same time. So it was like a completely different, way different. And like I wrote in the original one, there was some maybe legacy thing where a younger version of myself wrote some naive code. So obviously the code itself was better to begin with, but still it was completely different. The parallelism and and how Unity, how Dots utilizes SIMD instructions,
Mm-hmm.
and that cache efficiency that just blew everything out of the water completely the first time I tried it. I did the same thing with I worked on the skydiving game. I worked on this, a drag thing where so you can fly,
Yeah, yeah,
essentially.
yeah, yeah.
And I tried to make a leaf blowing simulation with that a few years later. So it's like just blowing leaves and simulate the leaves with the same kind of physics.
Right.
And every single leaf was a rigid body in traditional Unity.
Okay.
And I could have like 500 of them at the same time, and then it started to get
A little
weird.
chuggy. Yeah.
Yeah, especially since it was in VR as well.
Oh, okay.
Yeah, and then I re-implemented that into Dots, and bam, I had like 100,000 of them at the same time. So that was also like, oh, wait, this is it. This is how I can use this tech in real time with interesting combinations, and not just have like one thing visually for fun. The game can like mechanically depend on it a lot.
No,
So
that's fascinating that you kind of had these like existing projects, and you kind of like already knew the limitations of them. Like you had some like pretty hard limitations, and then when you went to implement them using Dots, like you were basically just able to like, sounds like almost immediately scale to just like crazy levels that are many times more than you were able to achieve.
Yeah, precisely. It was I don't know, liberating maybe the best word to describe it. It was like, because we made a trailer for Battleright where we had a bunch of leaves blowing in a wind in a map reveal. So, and we had like a character who was motion capped to like do a sword dance. I can link it later. And we had all these like purple leaves flying down, and I simulated all of those with that type of thing. But I had to do it in non-real time mode. When you can like lockstep simulate Unity.
Right.
And it took like forever to simulate all those leaves. But it looked good in the trailer, but it was nothing we could use anywhere near.
Yeah.
That's like peanuts compared to what we're doing in Just Read Instructions now.
Wow. Yeah, no, that's I think that's like one of the coolest parts for me with Dots is like, there's so much like traditionally in game development, there's like been so much like, faking things, which don't get me wrong is super cool that like, we've came to these like cool and weird solutions to like make things look like they're happening correctly. But then, with Dots, it's like we're actually like able to do these things like in real time. Like it's just like a completely different way of like going about the problem.
Yeah, you almost took the words out of my mouth there. I'm actually been fascinated with the concept of like doing stuff for real a long time, and when you make a flying game, it's whatever, we just like make some quaternion math and make it able to steer, and you don't have to like actually simulate the drag, whatever. Doesn't matter. I am like, no, this is the most fun part, being able to do it for real. That's where my like engineering fingers goes bananas, and I really want to work on that stuff, and Dots allows you to do that for real. The drag simulation is maybe not the best thing, because if you have just one plane, it's not a big deal. But having particles in the whole world.
That does bring up a good example, and I don't know exactly, obviously about how the back end of this game is made, but Microsoft Flight Simulator. I know in some of the like older versions of Microsoft Flight Simulator, they basically said that there were like some things like stalls, like when you like have the plane go like straight up and have it stall. That in some of the older versions of Microsoft Flight Simulator, like that was completely just like faked and hard coded in. Like when like certain values or whatever were set, then it would just like trigger a stall. But now in like the newer versions of it, again, I'm not sure if they're using like an entity component system or whatever on the back end, but they're actually able to like simulate drag at like hundreds of different like individual positions on the plane. And then then they can get much more realistic simulations. And like now when you do a stall in the latest version of Microsoft Flight Simulator, it's like actually real, like really simulating that with like the real wind physics and drag physics and
Yeah.
all that.
Yeah. I've actually seen a dev talk from those guys. Maybe you've seen the same thing where they talk about this thing and then, like, they show all of these dots and like
Yeah.
things
It's a
sticking out.
super cool video. Like you can,
Yeah.
I'd encourage anyone to look that up if they're interested.
Yeah. So yeah, that's it's you feel like, oh, there's so much more I can do now. That's my feeling when I think about dots. If I don't know, if there's it's an example of this stuff to show your audience would be fitting. I could link you something. It's up to you. And like
Like some of your sample projects, you mean?
yeah, like some
Like
of
if you got like
the
a video of it or something?
yeah, I have a video of
Yeah,
the
happy to share it.
simulating grass. Let me
Cool.
just
Yeah, I think
see
this
if
would
I.
be always fun to show, kind of like a little visual reference here.
Yes, exactly. So because I was when I discovered that huge difference, immediately I was like, what can I do with this? And the first thing I thought about was like, well, maybe I can like have tons of grass simulated for real and not just have a random shader doing the actual, because that's how you usually do it, right? You have like a shader that's
Right.
with
Yeah.
some with a sinus or cosine thing, and you just like, oh well, they go that way and then go that way and that's it, and have
Yeah.
fun with that sort of. But I thought that maybe I can actually do this properly, and I'm scrolling through my through my Reddit mentions, or not mentions, post here. I thought I had it in my. Sorry about the
Nice.
delay. There we go. It's inside. Should I link it here?
Just send it to me
Yeah.
in the Discord chat.
Yeah. It's Reddit. I just realized it was just a post to Reddit. I don't know if you can show that well.
All right. I am. Okay, we have this here. All right, so we got some grass in Unity with the gun here, and so okay, you're showing the like individual dot simulated chain with the GPU skin spline. It looks like this is that just like kind of one blade of grass essentially that you're
Yes,
just kind of like
exactly.
dragging around and.
Exactly.
All right, and then stiffened up a bit, so now it's like actually vertical and kind of moving it around, showing that it's simulating. You just have a single grass straw moving around.
And this is exactly how the palms worked in Battleright.
Okay.
So it's basically exactly the same math, and there we have.
And so now you're actually going through the grass, and you can see that it's interacting with. Oh, nice!
Yeah,
and so you're shooting into it, and they're all.
There's an overview in the end that's really.
Oh wow! It. Okay, I like this view a lot. You can when you're shooting into it, you just see that.
Yes, so that's completely impossible if you don't really do it multi-threaded and simmed cache optimized. You can't do that in that scale. So that's a very good example of dots just blowing everything out of the water.
That's incredible. And about how many blades of grass are in here? I'm trying to see if there's like
40,000.
40,000.
Yeah, I think I'm 90% sure about that. Yes,
I'll take 40, your word on it.
And my approximation was that it was 500 times faster than my normal implementation in traditional Unity.
Wow.
So yeah.
Awesome. So yeah, and then kind of talking about now moving on to like your project a little bit, like when you actually started developing this as like a project for real. How did kind of that all come about? Did that like were you kind of experimenting with dots before you started having the conversations with your friend about creating your own game studio and all that, or
it was very much everything parallel. We basically we decided to start a company like at the same time that we like proved the concepts. So I worked a lot on my spare time the first maybe 4 or 5 months. And I worked actually 3 months at a completely different studio for just do some work for hire stuff. So it was, it was a little bit of a side hustle thing from the start, and then we were like, no, let's just focus 100%. But the dots thing and the game concepts, they were very much tied together. It's hard. It's like the hen or the egg. Nothing really came before the other one. They both informed each other until we are where we are today. So yeah, that's sort of how it worked.
Nice. So it doesn't really seem like kind of the idea for the game came about before the tech, and the tech
No.
like you didn't say like, oh, this is some like cool tech, like what can I make with this? It sounds like those things both kind of happened like around the same time.
Well, yeah, it was trying, uh, just trying those two examples that I showed or talked about. There was like the seed for like what can we do, and but also like, oh, we can do this leaf simulation or particle simulation that we use in the game, and like, oh, what gameplay can we do with that? And so it was like it's completely it branched, and then into each other the whole journey, so to speak. We oh, this is the gameplay we can do. Oh, well, this gameplay requires this type of tech. Maybe we can do that as well. Oh yeah, well, maybe we can also expand on the tech and do this. And it's impossible to take apart almost, because it was so. But we really much followed the fun in the start. We just like, what's fun? This is
Yeah.
fun. This is fun. Let's try it. It's always tricky because this is a delay between the idea and implementation. So sometimes stuff get lost while you're implementing stuff that takes a few weeks to do. So in that sense, you get lost in the technical stuff, and then you forget sometimes what exactly the design decisions was. But generally, it was like just this is fun. Let's what can we do more with this? Oh, I discovered this new tech in dots, and we can do this. Let's try that. And so that's the whole first half year at least was just those things over and over again.
Nice. Cool. And yeah, kind of moving over to like the technical side of things a little bit. I see Joe Peters in the chat kind of asked an interesting question, talking a little bit about that grass simulation there. He says, but graphics cards are still a lot faster than ECS. Why simulate grass on the CPU? So I don't know.
Yeah.
Do you have kind of like experience with like graphics, like GPU programming at all? And can you kind of talk about that a little bit?
So compute shaders, like doing actual non graphics related stuff on the GPU. That's not something I've messed around with yet. I really want to get into it, but
Yeah,
he's
same.
completely right. I This is like the title of the Reddit post is like, this is a completely useless simulation. Basically,
Yeah, yeah.
it's what I say. This is a waste of CPU cycles.
Amusing
He's
waste of
completely right.
CPU cycles. I like that.
Yeah. So, but that was just a benchmark, like where
Right.
does.
It's kind of a tech demo, like kind of
Yeah,
to
exactly.
experiment like with the technology, and it was kind of related to something that you had already like had some experience with. So it's just kind of like more to prove the tech than to be like an actual like field of grass that you might have in like a production game.
Yes, exactly. It was tech demo and just like rule of cool. I think one can say like, this sounds cool. Let's do it.
Yeah.
Sometimes you need to do some silly things to like inspire yourself or something. But to like tie into the CPU versus GPU things, because that's a common argument when you see these like
Right.
huge quantities of stuff in ECS being simulated. Somebody is typing away like, oh well, you can do that on the GPU. Don't
Upload
bother
to the
with the CPU.
GPU.
Yeah, exactly. But sometimes like the channel back from the GPU is very weird and annoying to deal with. And sometimes you just want to have it on the CPU, because then it can integrate with the gameplay traits, like our particles. The simulated particles in just read instructions, those can easily be made in, well, not easily, but they are ripe for making a GPU implementation. And I will probably do that sometime for fun. But they hurt the player in our game. So they need to be calculated and compared to the player position every single frame. And if they were on the GPU, it would be a lot more piping and infrastructure to make that happen. And as well, it's not like we are still GPU bound, so it's not like we have so much things we can do on the GPU just for fun.
Right.
So yeah.
Yeah, and especially with dots, we can make games for lower powered devices where we can't necessarily always guarantee that they might have a strong enough GPU in their system.
Yeah, it's. I think I saw on one of your talks with Jason, maybe Jason
Wyman. Yeah.
Yeah, and he or you said something about the people say like, oh, this game is not appropriate for ECS, don't bother, it doesn't need a million entities or whatever. But that's missing the point. Performance is always nice, regardless in which context. It always makes a good impact on whatever device you're using, whether it's battery, power, heat generation, or just like raw FPS. So yeah, it's you need to realize, the people need to realize that it's more than just fun gameplay ideas.
Yeah. I mean, obviously there's these cool tech demos that we can do at the high end on our very powerful PCs, but at the same time there are like real life applications for being able to make maybe a little bit more complex games run on some of these lower powered devices. So there are absolutely is some benefit for that.
Yeah, and I feel the Unreal versus the Unity question, and like what they have done with Illumin and Enlighten and those two, the physics and the rendering stuff.
Yeah.
It's like, that's obviously super impressive. I was blown away when I saw that demo first time. But that's a little bit of a black box, I presume. Being able to just like, oh, we can just hack away on all the cores with perfect utilizations and cache with our own gameplay code if we wanted to. That power with dots, just like unlocking all of that, unlocking the optimizations that's probably in the core of Unreal Engine, but like in the core, and you don't mess with it.
Right.
That's like brought to the front, like anybody can use this in dots. Just have fun with it. I think that's super powerful and fun.
Awesome. Cool. So yeah, then kind of moving back to the development of your game a little bit. So you've been working on this for a little while. So do you remember kind of like what version of entities that you started with about?
Oh, which one I started with? That's a good question.
Because I'm sure you've had to kind of upgrade
13?
it. 13, okay.
013 or something like that.
And was it still on like you had to like inherit from component system for for all your systems?
No code generated for each lambda things. None of that. Everything was was in this iJob for each component, or
right,
whatever they were called. So we implemented like the first version of our game completely in that system. Well, not completely, but as far as we could take it, and have the multiplayer and the shooting working well with that early version. But we also had like, it was a bug that always crashed the whole game, like approximately a minute in. Like some physics wrote to the wrong part of memory and just like hard crash, and in the log it's just a like segmentation fault.
You're like,
we had like this for half a year. We couldn't play the game, and we knew that this was, well, I was almost certain that this was Unity's fault, because and they eventually fixed it. So that was like the biggest relief in my in past years.
You're like, oh, thank goodness.
We can play our game, Chippy.
So yeah, what was kind of like your experience going through like the upgrade process when these different versions of entities came out? And obviously it's changed quite a bit since you started. Are you on the latest version of entities right now, 0.17?
Yeah, I think we are on the latest version of everything, basically. Yeah, the upgrade. I think the integration with the physics engine was the most troublesome, because they didn't have fixed update for the first while, right? and we need a fixed update for a lot of different purposes. Or well, we had two routes. Either we could go fixed update, or we could like make the whole game around that the physics was not fixed update. We had those possibilities, like were reasonable possibilities, both of them. But that thing, when they actually introduced fixed time, whatever they call it, that was, I think I spent like a week going through and making everything connect properly when, you know, a lot of systems moved into this fixed update group.
Yeah.
Yeah, that was because, you know, you need to wait for stuff that's not in sync with you, and or you know, not wait for it. Yeah, that was probably the trickiest. Otherwise, I remember I was annoyed at the Lambda thing when they released that. I was like, this because I'm, you know, we struggled with garbage collection the whole battle, right? There was, you know, a big uphill battle to
Sure.
get rid of every garbage collection in the whole game almost. And well, I didn't realize how not a problem that was with the Lambda thing. It just looked so wrong to me. Like, I can't declare a damn Lambda every frame. Are you stupid? And then like 2 weeks after, like, oh yeah, this is much better. I realize now.
Yeah. I mean, just the composition of it all, it just like flows so nicely, I feel like.
Yeah, much better than the before, but they still have a lot of work to do on that. I think they can make it a lot easier if they really put some effort into it. But I guess that's why they aren't recommending dots for everybody. It's still got some kinks in the API streamlinedness, but it's much better than they started with, of course. But otherwise than that, I think the upgrading thing, which people have complained about a lot, that it changed, and you need to like, oh, this tutorial is too old, or and this stuff, and you can't upgrade this, or it's really annoying to upgrade. We didn't have much of those problems, so it was quite alright for us, actually.
That's great to hear. And yeah, I know we've been on the entities version 0.17 for a while, and
Yeah.
I don't know, it kind of seems like we're at the point where like most of the core stuff is kind of like staying the same. Like, you know, we're not having these like big sweeping changes like from component system to system base, and you know, changing everything from like where you're manually creating all the jobs using iJob for each, and now to a Lambda functions. Like, it seems like that stuff is a little bit more solid, and now it's just kind of like building out more of the features, and, you know, fixing some of the kind of like edge case bugs and things like that. Is that kind of how you see it as well?
Yeah, I think the core stuff and the core idea of like how Unity, how dots works and looks API wise in like runtime mode. I think that seems to be quite nice as it is right now, and
Yeah.
I hope that Unity stays with a lot of the decisions because I like them. But I think that the conversion part is probably the thing that they're gonna like probably throw up in there and remake once or twice.
Yeah.
But I think the conversion thing is the unsung hero of dots. I don't know if you agree, but like this thing with like having two different representations of your game, like it's much easier to build a development environment, and the tools and the work, everything around just the development is so easy when it's, you know, it's garbage collected, it's ref counted in all the ways, and you can just like throw class references all around the whole system, and just like everything talk to everything however you wish. Like, I think that's a very powerful thing for development, because then it's so easy to just get something up and running, or get something up and like defined properly, at least. And the tools also so much easier to work with, and then convert that into a form that actually makes sense for the cache and the CPU. I think that conversion is really a powerful idea.
Yeah, that's
And
interesting. The last couple of developers that I've talked to, they've kind of been all over the place. Like, some use a little bit of the conversion workflow, some don't use it at all. But it sounds like you use it pretty heavily, and I definitely like the conversion workflow. It's just you know, nice and easy to just get something up and running quickly. So, but yeah, it sounds like you use it a lot for your game.
Yeah, we don't use the subscene stuff at all. We don't really need it since we generate the game, the scene every time, and we actually generate the whole game in traditional Unity code and then convert it. And that's also like a good case for the old Unity ways.
Like, are you talking about the like procedural generation side
yes.
for your game? Okay, so interesting.
Yes.
So you do that all basically
in traditional
just like
Unity.
wow, and then kind of in your conversion process, then that gets all converted to ECS stuff.
Yes, that's possibly the hackiest thing in the game. It's not that hacky, but it's still like a little bit of hack. You know, you need to like make everything be disabled, and then when everything is generated and everything is hooked up in the mono behaviors, so everything knows about each other, and then like in one frame, turn everything on so it converts at the same time and hooks up properly. That delay in conversion to wait for everything. That's possibly the strangest implementation into game, but it works. And I think the building blocks of using transforms to make procedural generated stuff with transforms, that's the powerful thing. I think transforms are a really nice just utility to use to work with space.
Nice, awesome. And oh yeah, I was just gonna ask and so kind of what was the decision for using like the traditional Unity for that generation? Kind of why did you go down that route?
Ordering stuff. So first of all, like people don't think about that too much, I guess, but like the whole everything in Unity in a scene is built around this child parent transform paradigm, right? And in dots, that's not really a thing except for positioning. But like if you disable a game object, every child gets disabled, right? But if you disable a parent in an ECS, the children doesn't get disabled. And that hierarchical stuff and with how well the transform works with all the math functions about moving transforms in and out of each other's and parenting and moving them locally and globally and everything like that. That's like the Swiss Army knife of working with space. So that's why it's hard as it is to make a procedurally generated world. Let's not complicate it even more. Let's try and see if we can make it using transforms. That is such a good tool, and then afterwards convert it. And maybe the loading times will be longer, and we need to like make it eventually in dots. Maybe, probably not. But the loading times is essentially the biggest issue with this. It works great otherwise. So I think it was a good decision because moving around stuff in space in dots is tricky. It's not that easy in my view.
Nice. Yeah, that makes a lot of sense. I know the whole transforms and parenting stuff in the ECS world can get like super confusing and in depth, and just the traditional way of doing it in Unity. It makes a lot of sense. It's easy to use, so might as well use that.
Yeah, exactly.
Oh, that's super cool. All right, so I think we can kind of move on to maybe talking about like networking a little bit. So
Nice.
Joe Peters was asking a little earlier. He said, "How have you designed the networking part, and is there physics involved in your netcode?"
So first of all, we decided early on to not use netcode, Unity's ECS network architecture, and just for the same reason not use subscenes. It was like there's enough preview beta alpha things in our pot already.
So you're like limit the amount of experimental features we're using.
Yes, and I worked with the networking before, so I realized that I can probably mimic Batterite's foundation a little bit.
Nice.
It didn't turn out at all the same. It's really different type of architecture, but so we use an open source, an old C# open source library called Leadgren Networking.
Okay.
which is basically just a bit packer with and that helps you with setting up the connection server client style with the NIT punch through and stuff like that. That's what we used in all the games at Stunlock. So I married that as well as I could with dots, and um, this actually a little bit of a tangent, but it's a really good illustration of the weirdness of dots, positive weirdness. But I don't know if you agree, but dots it's way less dynamic in a very specific way. It's sort of hard typed in a very specific way. Do you understand what I mean?
Like you're talking about like the way components and systems kind of like
Yeah,
you code systems for working with specific archetypes and all that.
exactly. And you have you don't really have this dynamic memory everywhere. A dictionary or a native hash map, as it's called in dots, is it's a big deal to use that. It's not something that you just whip around like you do with dictionaries in C sharp. At least not for me. So that type of hard um, hardness and rigidity in the typing of the language, or how dots work, that was like kind of a big question mark. How do you make networking around that? Because you don't want to write all the individual like serializing things by hand. You want to have like some declaration, like, oh, this is supposed to be synced, and then that variable gets synced somehow. So I couldn't for the life of me figure out how I was supposed to do that. And I had purposely not looked at the previous example, like Unities. And then an old colleague of mine, we were at the place, and I asked him like quickly, like, just, like how, because they are using also dots at my old place. And I asked him like, how did you do the networking in your game? Can you have like just like a keyword for something that you utilize? And he's like, yeah, code generation. And like 2 seconds, I was like, oh, I understand everything now. I realized exactly how you're supposed to handle it. And Unity does that, does the netcode with code generation as well. So
Okay.
then you don't have this dynamic problem of having to have like references to all things dynamic references to everything in the game, and like serializing it like in loops and different stuff, because you can just generate the code that explicitly serializing every single individual variable by hand, but you just generate it, so you don't have to write it. So I wrote a code generator for our game, and that generated the whole serialization system for our game, and just put it into a native byte array, and off it goes to the network.
Wow.
Yeah, it was really fun to make. So
Oh
I
yeah, I'm
don't
sure.
regret. Yeah.
I know.
And
Go ahead.
to just continue on the question, physics. Yeah, we have physics, but it's basically just either we have physics that is just run by the server, and the server just syncs position and some velocity very naively, but we don't have a lot of physics, so it works. Or we have the characters, which are way more dynamic and need to be precise. And I built I think it's like a 3 second interpolation frame buffer system, where it like plots everything on a curve and tries to interpolate the character based on all available data every single frame, and make the most sense of where you're at and where everybody else at.
Yeah.
And that was very, very tricky to make that interpolation system, but our characters are very smooth, so it was worth it.
Nice. And so, do you do kind of any of that stuff like you're talking about a little earlier, like when you were working with your development company, where you can kind of keep track of like all the physics frames and kind of roll back and make changes if necessary?
Not anything at all, basically. That's the beauty of the genre we've chosen, because since we are a co-op game, there's no sense of fairness that we need to keep up and roll back and resimulate and everything. So the game is on purpose completely programmed very, very simple and naively network-wise.
Nice.
So
Okay.
on your own computer, whatever you shoot on, it dies. and it doesn't matter what anybody else thinks, and that just simplifies so much stuff. But since it's co-op, it will not matter at all, I think.
Nice. Awesome. So kind of just talking about like your experience with dots in general. I guess kind of how has it been just overall from a high level? I think we can kind of start there.
Yeah. So the first thing that I think it's dots has forced me to become a way better developer. That's the first thing that's weird, but
In what
well, maybe.
sense?
So it's hard to untangle. So like, there's a quote from Mike Acton, who is a lead engineer at Unity or something. He's one of the brains behind Dots,
Right.
and he said something about generics, like templates in different languages. It's like templates are invented. It's for people who want to invent problems to solve. Like, oh, I can make this list work with anything, or I can make this system work with any data type. And you're like, well, you're not using it for any other data type. You're just using it for this in your game. Why do you make the trouble of implementing as a
Why is it
generics?
generic if you're using it in one place?
Yeah, exactly. But like, we as engineers, we like to solve these problems. It's fun to make
Yeah,
it
you're
so
like, oh, but it
generalized.
can. We can
Yeah,
use it anywhere.
exactly, there's support for it. Yeah, so and that's, that's something you go through, I guess, and I went through it, and I came sort of coming out somewhere on the other side, and like realizing, like, yeah, you should just implement what you need, and you should be super precise about it, and do exactly what it's supposed to do, and I mean, there's no point in making stuff anti generic, but
Right.
still, like, don't go out of your way to try to generalize stuff on the first try. Just refactor. Go half a year later,
Yeah,
realize the
wait till you
patterns.
wait till maybe you need it. Maybe you're using it actually like 2 or 3 times, and then you kind of see like, okay, this actually would make sense to make this a little more generic.
Yeah, exactly. And it doesn't. It applies to all different paradigms of programming. I think everything is like. You should ask yourself, will this maybe be a fun thing to have in the game? And maybe if it's like a really low hanging fruit, sure, implement that as well. But otherwise, like, no, screw it. That doesn't matter yet. Let's just go forward, and let's just make this work, and that's not like ugly code in my mind anymore. At least it's just like efficient, smart code. And if you write it verbose enough, I think it's almost easier to follow your own code when you write it very specifically for what you're doing.
Okay.
And
Yeah.
since Dots is so less dynamic in the way you program it, it forced me to make more clear-cut decisions, like, let's do this exact thing, and let's not generalize a system for it or something like that. And in some sense, some things are way easier to generalize in Dots, but still, it's forced me to be more efficient and smarter about what I choose. So that's very high level.
Nice.
Yeah. Should I go further into more depth, or?
So actually, here's something that I kind of wanted to ask you about that is kind of still a little bit more high level, but I guess just kind of talking about like data-oriented programming in general. So it sounds like you kind of came from like an object-oriented programming background. Is that right?
Yes.
And
absolutely.
so I guess how has it been kind of like changing your mindset to kind of more of like a data-oriented way of thinking about things? What are kind of some of the challenges that you found, and what are some of the kind of cool things that you've been able to accomplish using this kind of data-oriented mindset?
So first of all, it's like it's still an uphill battle sometimes with pulling out
Always
all the
learning.
pulling out all the object-oriented thoughts out of my head. Like,
Yeah.
no, that's not the correct way. And it's weird how you get taught, like, this is the way, this is how you code, and just do it. And then you realize that, like, if you code it way more non-object oriented, way uglier, it's much more much
Right.
faster.
Yeah.
It's so much faster and
Yeah.
irrelevant of Dots, just like how you can code stuff in a different way. And so, yeah, how have it's affects, like, now it's like I'm breathing it all every day. So it's almost like, how could I be so stupid? Now I don't want to call everybody who program object-oriented stupid. That's
No,
not
no, no.
what I
Yeah,
meant.
yeah,
But
yeah.
how could I be so stupid to think that this needs to be objects everywhere? And like, it's so much cleaner to separate it. And like the separation part with ECS specifically, like entity and component and systems, that's also like, it's just ties everything together. And it makes you realize that, like, for instance, private variables, where does that anytime matter in a game that you just developing at breakneck speed? It's like nobody's going to look at your API and like, oh well, I can come up, I can maybe you have like a big studio and you have designers who use your API, then I guess it's appropriate. But otherwise, it's like all this object oriented with private and protected and polymorphism and all that stuff. It's like you don't really need that in a lot of cases with just when you're just trying to make the product and make it run as fast as possible. So taking away that like syntax sugary type of drawn, like, oh, this should be private, and oh, I can expose
Sure.
this to this type of API, and that's beautiful or something. Taking away that is very liberating, actually. So that's a big takeaway.
Nice. Yeah, that's an interesting way of looking at that. But yeah, shoot, I was gonna say something. Yeah, I mean, there's just a lot of cool things that you can do with data-oriented programming. And I kind of remember what I was gonna say. You know, to be fair, for object-oriented programming, it makes a lot of sense for us humans. Like, we're just so used to just like interacting with like actual objects. So like, I have this like keyboard in front of me, and this keyboard has properties, and it also has things that I do. When I press the space bar, something happens, right? When I press the enter key, something happens. Like it makes sense that I look at this keyboard, it has data essentially, and functions associated with it. But when you move over to like object oriented, or data oriented, and you start like thinking about it, like it makes a lot more sense for the computer. Like you can have all this data, like all this relevant data, packed together very nicely. And then you can, create these like systems where you operate on, these sections of data, that are very similar. So like it makes a lot more sense when you think about, how the computer actually processes data.
Yeah, and you're completely. I agree totally. That's why I think the conversion state is such an unsung hero, because
you kind of have the best of both worlds. Like it makes sense for us humans, and we can kind of like implement that, and then we still get those performance benefits on the computing side.
Exactly, and of course you're gonna have to program it data oriented at some point if you want to use. The conversion state is not magic, obviously, but and to also to give object oriented some cred, it's way easier to learn programming via object oriented, and I want everybody to be able to learn programming that is interested. So if that's what it takes, obviously object oriented is a good thing.
Yeah. So I guess this would be kind of like an interesting little tangent, I guess, about learning it in general. I know it seems like Unity kind of wants their dot stuff eventually to be, really accessible to everyone. And so, things like the conversion workflow and maybe some other types of like visual programming will be how we see that. But do you think that like object-oriented programming is kind of like almost a necessary stepping stone into learning data-oriented programming? Like you kind of get your feet wet a little bit with the object-oriented stuff, learn how like variables and functions work, and then as you start to get deeper and kind of like learn a little bit more about how computers process data and all that, then you can kind of move to this like data-oriented way of thinking of things. Do you kind of agree with that?
That's a very, very good question. I haven't thought about that.
Kind of a tough one.
If I had somebody who's really interested in programming but don't know anything, it's like a blank page, right?
Right.
Should you
be like, oh, go learn about these entity command buffers and all these like.
to be fair, that's ECS specific and maybe also like dot specific. I mean, so, but I thought like programming stuff without thinking about it as object to begin with. Just like sidestepping object orientation a little bit and like saying like, well, you can have just bundles of data and then you can make static functions and you can make a game out of that, obviously. Maybe there would be some benefit of putting somebody on that track from the start. I don't know. But
Yeah.
it's a good question of if you want to learn it from the start, should you just skip object oriented if you want to be a game programming with high performance stuff in the end? That's a good question. I don't know, actually.
Yeah, no, I think
Interesting
it'll be,
observation.
yeah, I think it'll be interesting. These are kind of the things that I think about, obviously as I'm like, making these tutorial videos and like teaching people about this. It's like, kind of how do I frame this? I know most of the videos that I'm making, I feel like are kind of geared towards people who are already experienced at programming. But yeah, it's just kind of like a curious thought about, if someone's kind of never programmed something before, is it, realistic that they can kind of pick up something like Unity ECS and start actually like developing a project with it.
Yeah. Then you should do some A and B comparison. Like,
Right.
Find somebody who's just starting out with dots and see what happens.
Yeah, seriously. But yeah, and then I guess kind of going back to some of the data-oriented programming stuff in general, are there any kind of like cool tricks that you've done, like data-oriented specific things? I know like as I've kind of been like researching a little bit more into like data-oriented stuff in general, I mean, there's a lot of like really cool stuff that you can do. Like for instance, one of them is like actually like duplicating data and then using something like a shared component in order to like organize that data, even if it's the same data, but you're organizing it in different ways to like optimize the way you process it. So like in some scenarios, you might want to process the data when it's organized in one way, and in other scenarios it might be better to process it when it's organized another way. I don't know if that makes sense at all.
So like the organization of the data itself have some implicit...
Yeah, so you're kind of like optimizing for different cases a little bit.
Oh, right. I see what you mean. Yeah.
So like there might be like some different results in your game, and like actually like checking all your data for that specific result. It might make sense to process that data when it's organized in one way to find that result, but it's not super efficient if you're looking at like a different result.
Yeah, I think that's actually something that when I thought about this talk and like what's something that I think is irrelevant with dots, and that's like almost exactly what I thought about. It's like linear. I don't know how to pronounce it. Almost serializing your data processing and like unwrapping loops and making like pre-processing data to make it possible to process everything linearly, right? So
Yeah.
That's one. That's I think that's people don't get taught enough. I've only learned this because of experience. I haven't looked in a book too much about the concept of like, well, you have this data and it's like scattered or whatever, and it's like in the wrong format, and you can make a brute force 4 levels nested for loop to solve this problem.
Right.
Or you can just make these few things that just crunch it and put it in a linear way in memory, and it will be like 10 times faster instantly. Data oriented design is like pushes you towards that goal, I guess. And I think that's people should know that that's better than just like brute forcing the data. And that's a good observation. I think dots really requires you to do that because you can't have a for each in a for each, right?
Yeah.
So you need to process a lot of data to be able to do it properly in a one for each in the end.
Yeah, no, I
Yeah.
think it's kind of cool to think about these different problems, and with the data-oriented stuff, we kind of have different solutions about going about things, optimizing for different cases and all that.
Yeah, it's very unintuitive sometimes when you optimize something and you realize like there is this, I can fiddle all I want with the specifics of the code. It doesn't matter. It won't make a big difference. And then you like realize, well, I should just like spend all this time before doing this different doing this transformation of the data, and then I can have a following algorithm that is much simpler, and those two together is much faster than the original idea. And yeah, that's something that people should actually you should. I wasn't taught that enough, I think, to
Well, I
realize
mean,
like
this is obviously like pretty new to Unity, and there's not a ton of resources about data-oriented stuff online. But one thing that I, keep kind of coming back to, always seeing is like, you always want to, especially with data-oriented programming, you want to optimize for the most likely scenario.
yeah.
There could be a bunch of different things that happen in your game, and obviously all these weird edge cases. But you really want to optimize for the things that are maybe going to be happening every frame, or what's the most likely outcome of some particular thing happening in your game. So is that kind of like a mindset, I guess, that you employ in your development?
I think not necessarily about doing the most common thing the fastest. Maybe this is an additional level up I have in my future to realize how I can view my own code in that way. So no, it doesn't. Well, I mean, there are some cases where I make decisions on what's going to happen the most time, but it's more about just making sure that I understand what form the data is in, and like realizing how I can use that. Then but yeah, maybe I should think more about uh, doing the common case the
Yeah, are
best
you
I
gonna like
can.
jump off this call and all of a sudden like rewrite your whole code base?
Yeah, well, wouldn't be the first time.
Nice. So yeah, kind of want to start getting into some viewer questions here. I do see that we have one from Joe, and of course, if anyone else has any questions, feel free to just leave them in the YouTube chat here. So I did kind of want to ask you a couple things related to this, anyways. So this question from Joe says, "Where have you learned your dot stuff, except the bad documentation and my videos? Where do you get your information?"
Source code. That's it.
Nice. Yeah. Yeah.
I
I
just
feel
read
like
the
the
source
the
code.
source code, I haven't dove into it too much myself. I've looked into it a little bit, but there is some good information inside there. So do you have any tips for kind of like going through the source
Yeah.
code?
Yes, maybe this is common case, and everybody knows it. But if you, I think it's like has been in Unity, the editor for like a year or two. If you go into preferences, not project settings, preferences and external tools, you can check the box. Let me just find it here and see what it said. There's like the options is generate CS profiles for, and then you have like a bunch of different categories of projects that will be compiled into your Unity project. And there's something called registry packages. And if you check that and you press regenerate project files, you get all of the dots code, basically way more than you need,
Mm,
compiled and accessible, linked and everything right into your Visual Studio product. Have you
nice.
seen that?
Interesting. I have not. No, I've so I use Rider, and I've basically just
Oh,
used like the decompiler to just kind of like go through, like you can kind of
oh,
like
but
dive into it through there.
you don't need to the source code is checked out on your in your library map folder. It's all
Yeah, I don't think it really needs to do any decompiling. I think I can just go into it. I don't remember exactly how I've gotten to it, but
uh,
it's been pretty
well,
easy just through the IDE.
yeah. In Visual Studio, if you have it normally set up and you press in the stack trace straight into some dots stuff, you end up like in this file which is tagged like a miscellaneous file, right? So it's like doesn't really belong to any project that Visual Studio knows about.
Mm-hmm.
So you can't jump around through the definitions. It's just a text file you're viewing. But if you check that box and reload Visual Studio, you will have all the packages that comes with dots compiled and linked in properly, so you can like follow the code and you can even debug it if you want to. So I've delved deep into the source code several times. I've stepped through physics steps with the debugger to find in vain to just get it out of there, because it wasn't my fault to begin with. I found like 4 or 5 different bugs in dots while debugging it.
Oh wow.
And I'm too lazy to follow that bug reports. So I'm just like, oh well, I can work around this, I guess.
Nice. No, yeah. I think that's some good recommendations, and you kind of have like a better understanding about like how it actually works when you kind of go through that source code.
It's like it's almost eerie the first time you like follow some interesting aspect of the dots code, like how end simulation command buffer system or whatever that how they actually work. They are really simple. You can just follow everything, how they sync up the different thread and execute the command buffer afterwards and stuff like that. So I encourage everybody who is well versed in programming to begin with. I think it requires a lot of programming knowledge to just dive into it and see what happens, because I've like mimicked a bunch of stuff from the source code because like, oh, this is how you're supposed to do it. Let's just copy this out and make my own version of it. So source code that's super helpful.
Is there anything, any particular specific things in the source code that you recommend people should go through, or some things that you found particularly interesting?
Yeah, let's see here. So the end simulation command buffers. That's for the end stages of the 3 different stages of ECS simulation. Because when you see how they and that's basically how they interact with system base, with the more or less the execution order managing. I think that's something that you need to realize. Like, only from the source code did I realize that if you don't have an entity that runs, if it doesn't have an entity that actually matches a for each loop inside your system, the system will just automatically disable.
Right. Yeah.
And that's in documentations all over the place probably, but I didn't realize how that worked until I like actually stepped through and realized a bug I had was I could see like, oh, it just calls a function and checks the existence of these chunks, and then it goes for just straight C#. It's super easy to learn and to read. So the base of system base and simulations command buffer, such a long name.
Yeah.
those two classes, those two are very, very integral to how the execution order works, and that's really helpful to know.
Nice. Yeah, I definitely, you got me interested to look into those and see what it's all about now.
Let me just do a reverse and say something that you should not look into.
Okay.
And that's how entity command buffers are implemented. I was trying to make my own version that only.
So just look into the command buffer system, the thing that just runs the command buffer, but not the actual command buffer itself.
The command buffer itself is so much weird stuff. I have no idea what happens then there, and I spent like a day looking through that code because I wanted to mimic it in my own way. Just like my brain exploded and I just gave up. It's stupidly complicated from my perspective.
That's hilarious. That kind of reminds me of something I wanted to ask you about. Have you looked into like the source code for adding components at all? Because I know like I think it's in the Unity like Dots best practices documentation. It lists out like the kind of like high level steps about what happens when you just add a component to an entity. and there's like 7 or 8 things that it goes through, and like, you know, it checks to see if that archetype is already available. You know, if it's not available, then, you know, it's going to create that archetype. And there's a lot of like memory management stuff going on. So have you dove into like adding components in the source code at all?
Yeah, a little bit, for sure. I haven't. You know, the source code sort of ends in some places because, like, I guess it's a combination of like this is really something that should be written in C or C++ or something like that, and also like some things are just not that possible to do in C#. So they like go out in a native code utility, whatever they call it. They have like this
Yeah.
utility function that does a bunch of native stuff for you, and you can follow the code, but so much stuff happens behind that compiled native code that it's not. From my little small peek, it wasn't that helpful to anything. It was just like, oh well, there's a bunch of code here that is really hard to follow. I guess bye bye.
Yeah, no, that makes sense. And even in that kind of best practices documentation, it talks about some of like the actual like C++ functions that it's using. Like it's using like memory copy to, you know, copy memory to different locations, like, you know, very like low level programming.
Yeah, that's because they have this chunk system in the bottom of dots. I guess they get so much stuff for free by just using proper organized mem copy in different ways, realigning different stuff and like swapping out big chunks of components, taking them away and stuff. That's yeah, it's nice. It's interesting to see how much you can get performance out of that by just doing it properly linearly in the native code.
Nice. And then so talking about not necessarily like going into the source code, but just kind of generally with dots and ECS, like what do you think are some of like the most fundamental concepts that people should understand? Like, you know, what are the important things that you end up using a lot? Like what kind of things should people know?
Properly understanding how you should tackle in what steps you should tackle the data transformations. And that goes back to what we talked about. You talked about data-oriented design, and you know how different forms of data, like the same essential information, can be arranged in different ways, and that can like tell the different system how they should execute on them. But like if you sort of reverse that thing, or not the reverse, but take it from the other perspective, like how do I get this stuff into a proper format to be able to execute on it? And like dots doesn't really allow you to do it in a naive way, because you, like I say, you can't have a nested for each loop. It just doesn't work. So that's something that I think people should really like take to heart. Like, oh, I have all this data, I need to process this in that way. And normally I would just have like 2 or 3 nested for loops and be done with it. But like realizing that there's so much more effective ways of doing this by just processing and understanding the format of your data, and maybe like just like realizing that, oh, this doesn't need to be here, or this should be laid out in like the opposite dimension. If you like had like a 2D array or something, like if we just swap it everything and like make this go first and that after. It's so organizing your data in relation to your for each loops, that's truly fundamental to me when I design stuff. From like what's actually an entity and what actually is the component that matters to the processing of the data.
Yeah, that's a good point. Like really like fundamentally understanding your data. You know, like, you know, what's the data you have, you know, how are you transforming in that, you know, what's kind of the data that you're going to have afterwards. That, you know, that makes a lot of sense.
And not think about it like, oh well, this makes sense together because that's like an object or whatever with these 3
Right.
combinations of
Yeah,
components.
yeah,
No,
yeah.
that doesn't matter. It's not that way. Like what is the processing that these components are involved in, and how do we optimize that processing by aligning the data?
Yeah, that is a good point. So I was kind of going back through some of the questions here. So I see Fredo asked one, how do you manage the character animations in dots?
We don't. That's the question.
Yep.
That's the answer. So we just do it hybrid wise. I've looked into there's a little bit
To
to
use kind of
unpack
like the
there.
managed data components, basically.
Well, yes, we do actually do that. We didn't start with that, but I converted it a few months ago, so it does that. For me, it's a little bit easier to do it with the managed data ECS component thing, but it's like you can still get by without connecting the mono behaviors directly to an entity. It's easy to do the connection
Yeah.
yourself if you
Yeah.
want to.
Yeah, and just for
And
anyone who doesn't know what a managed data component is, it's basically just a class that implements the iComponent data interface as opposed to a struct. I know in the video that I did about UI and ECS, I kind of show off how to use those managed data components. And basically, you can use those managed data components to integrate with things in traditional Unity programming, just mono behaviors and whatever.
actually watched your video and came up with a nice refactor that I will probably make in my own game.
Nice, that's
Like,
awesome to hear.
yeah, there was like some little detail of it. Yeah, it was the on change filter. I was like, oh wait, I knew this, but I can use it. I'm like, yeah, it sort of refreshed my memory of, and I realized I can
Oh,
refactor
cool.
something based on it. So that was nice. But to just continue a little bit on that, we have a lot of animation in dots, and I've actually made like the traditional old school animation in dots that doesn't work with skinning at all, just like animation. I actually made a whole. I replicated that whole system in dots so we can animate stuff. Um, we can animate stuff with the traditional Unity animator, like moving cubes and whatever. And then when we press play, I convert everything to dots, so we still have an animation that works, but purely in dots. Did it die?
My camera died. I'm just replacing the battery here. So I'm still here. We just got a black screen
you have
on
two cameras,
on this.
Oh.
Yeah. I got the webcam plugged up here. I really need to get a power adapter if I want to start doing more of these live streams. But yeah, this has been awesome
right.
so far. We can probably go maybe just a little bit longer here. By the way, if you are enjoying the stream, whoops, hit the microphone there. If you are enjoying the stream, make sure you hit that like button. Let me know if you do want to see any more of these. Let's see, I think.
Now I don't hear you.
Can you hear me at all?
No, yeah, now I was back.
Okay, I was kind of like off the mic a little bit. Let me,
and the third and final thing with animation, which I think is really nice, the way the crawlers in the game moves. You've seen it like where it's like follows the walls and everything, right?
Yeah.
That's made with a custom shader and with dots instancing, the new instancing framework that they have, where you can just push over a bunch of data in a big array to the GPU, and being able to do that low level stuff with like having all these positions of the feet of all the crawlers and push that straight over to the GPU in one go. That's without that we couldn't have done all the crawlers.
Oh wow, okay.
So that's something that people that's you don't realize how much you can do if you can get actually all this array just straight over to the GPU and just go for it. That's instancing in a nutshell, I guess, but it's very powerful and nice to use with dots.
Nice.
Does it work? I just kept on chugging.
Well, the camera is up, but it is not opening up in OBS here.
Oh, right. Yeah.
Yeah, trying to do a little bit of technical support on the fly doesn't always go exactly how you want it to. I mean, the camera shows that it's connected, so let me try to deactivate and reactivate. Oh, okay. We have it now, but it is scaled way off. And all right. Okay. No, that's over you. All right. Yeah, I think that's good enough to finish the
uh,
stream.
that's nice.
Okay. Um, so yeah, if anyone else has any kind of last questions here, we can probably start to kind of wrap this up soon. I know this has been
I saw a comment that I feel
yeah,
that
yeah.
made me
Please,
feel
please.
a little bit stupid here. He says, but Yo Peter says you can do a double loop, and sometimes you just need a double loop for a lot of ON2 algorithms. And you know what? Yes, I think I read about this, and I really didn't think about it too hard and just moved on. But do you know about this? Can you make a for loop inside of a for each loop inside of a for each loop in dots?
Um, I didn't.
Unbursted and everything.
I didn't think you could. Why can
I
you?
have some vague memory of something, but maybe he can fill in. But if you can burst it and everything, it just works like a charm and paralyzable
Yeah, I
and
don't
everything.
think you can.
No, I don't think you can either. But I read somewhere about something nested in dots with the
There's like a
trick.
way that you, kind of a workaround you can do.
Yeah, I don't remember.
So Joe says he made
Yes,
one for his planet simulation.
that's a very good use case for that. Doing the iterative gravity things. I guess that's really annoying to do linearly.
So could those be two separate like entity queries for those for each loops then?
That's a good question. Maybe it's like you can iterate on your neighbor or like somebody, but it's still the same query or something like that. Yeah, we need to look this up, or maybe Joe can just. There's a video from Code Monkey where he's shown how to do it. All right, then I'll know what I'll
Sweet.
do after this stream.
Yeah, exactly.
Yes, and also somebody asked about scripting in Dots.
Yeah,
Have you
yeah.
looked into this?
Like what do you mean?
Scripting, like not non-compiling code in some sense, I guess, hot reload code, something. Because I've worked with that in Docs a little bit.
Okay.
I
Yeah,
can
if you
talk
have
about
some
it.
experience with that, feel free to, yeah.
Yeah. So Unity released their visual scripting thing like a year ago, maybe 2 years ago, and they had like beta dumps where they like, oh, this is the latest version, try it out,
Yeah.
and then they like just dropped it because they like completely rethought the whole concept of visual programming. So that's not a thing anymore. That otherwise would be a very good scripting framework, I think. I tried it and it worked really well. It was connecting dots and nodes and stuff, and it worked pretty good.
Oh, cool.
But otherwise, the tricky thing with dots is with like meta programming like that, with hot reloading and stuff, is that a lot of the code that you write in the for each loops, that is like the critical performance code, that's code generated to something else in the end because of lambda expressions being compiled to something else.
Yeah.
So it's really hard to make fast code scriptable because they need to be compiled in some way and converted, and it's hard to hook up into that system that dots have. But I managed to do a hot reloaded code with in C# you can hot reload code and compile it on the fly if you want to, but then it's basically just accessing entity manager straight up, not bursted, not paralyzed, nothing. Just like you can do scriptable hot reloadable code like that, but it's very slow if you need to scale it.
Interesting. What would you say the kind of best use cases for that are right now, if any?
Orchestrating complex interactions between that is like very singular in its quantity or something. Like our instruction in our game is quite ripe for this, but we decided not to do it because it's so slow and it's a little bit annoying to code in. But when you have like, oh, we need to change this tiny thing, it's not about 50,000 entities or something like that. It's just like this one switch over here that needs to flip in this situation. So like orchestrating a lot of different gameplay elements. That's where you know a visual scripting language or just hot reloaded code really helps a lot. Back to right was completely hot reloaded. Every single like ability and character, everything was completely. You could just like press save when you added a line, and it just in like milliseconds you were running with a new code in game. That's super powerful, but it has some use cases and it has some very stupid ways to use it as well. So you need to be careful with it.
Nice. Yeah, that's super interesting. Were there any kind of other kind of like big topics that you had in mind? Some things that you wanted to go over at all, or anything else you wanted to talk about at all?
It was the structuring your problems and conversion states. That was two things that I think is very important with dots that I thought about. Yeah, otherwise, no, you covered it all, I think.
Awesome. Yeah, this was a totally fun talk. I mean, we've actually been going for almost about 2 hours, so time just completely flew by. I didn't realize how long we were going for.
No problem for my sake.
Yeah, no. And thanks for being patient. I know I was kind of having some internet issues earlier this morning. So it's like, of course, you know, the day that I wanted to do a live stream that, you know, the internet goes down and all that. But yeah, thanks again for being patient. Thanks again for everyone showing up. Oh, what's going on, Drew? Thanks for the super chat. Go Team Orange, indeed. Thank you, man. Let's see. One thing, just kind of an update on that from Joe. He basically said you push the whole array into every job, so that kind of makes sense.
Yeah.
But yeah, I'll definitely go check out that video from Code Monkey as well.
Also, I think you maybe I missed in your video library, but I think you should do a tutorial on blob assets. Have you done that?
Yeah, stay tuned in the next couple of weeks. I actually just recorded one the other day, so
nice,
coming up
nice.
in a couple of weeks here.
It's a good thing to use.
Yeah, definitely. I think there is some very good use cases for them. So yeah. So once again, everyone, make sure you go Wishlist. Just read the instructions. I think it's a really cool looking game. Do you kind of have any timeline for a release that you want to talk about at all? Like, I think you mentioned that you kind of want to get like a public beta kind of thing in at some point.
Yeah, so we were like aiming for a beta in like August, September, but maybe we aren't really time constrained right now, but you know, you should be sometimes to get the stuff out. So we're trying to just force it out. We are waiting for a little bit of music and a little bit of sound effects. Not waiting, but you know, it needs to fall into place as well. So who knows? Maybe 2 months, maybe 1 month, maybe 4 months, somewhere around there, a demo. And like at the maybe I should post that at our website. Oh, you can actually see that on the store page. There's like a sign up for beta button on the middle.
Oh, okay. Yeah. So just if anyone
button,
goes to the Steam page, just scroll down a little bit. It says early beta access, sign up for beta. So actually I will do that myself.
Yeah. So and as we say on the website where we take your email, we won't spam you with anything at all until we have something for you to play. And that's sort of a value proposition. Like,
nice.
You know, everybody hates this all spam about all random stuff that you need to clean up in your inbox. Like, unless we have a beta for you, you don't worry. We won't spam you.
Great. And then
so please sign up for that. That's a great thing.
Yeah. I think it's a great looking game. You know, compliments to your artist. I think you know it's a very visually appealing game. And you know, looks like it's a ton of fun to play. One last question for you: how do you say the name of your studio?
Yes, in Swedish it's Knacklebang.
Knacklebang.
Knacklebang. Just a simple G in the end. So no Knacklebang.
Clackly binding.
Don't
That's a
worry about
tough
it.
word for
You
me.
can. I actually encourage non Swedish speakers to just pronounce it as it sounds in English or looks in English, like knackly bang or something. It's
Oh,
not.
knackly
It's
bang. Okay.
yeah, and just have fun with it. It's not a big deal. It's a slang for knock knock in Swedish.
Oh, cool.
That's why our logo is like a guy kicking down the door.
I see. Okay.
Yeah, yeah.
Cool.
So, but knackly bang, yeah.
Nice. Awesome. Well, yeah. Thanks again, Tobias, for joining me. Thanks again for everyone else hanging out in chat. I think there were some good questions. We talked a lot about ECS stuff, so I think this was a really good talk.
Yeah, it was super fun.
Yeah, yeah.
Really
And
fun.
do you where should people follow you online? If do you have a Twitter
Oh,
account? I know your studio has one. I think I put the your studio's Twitter in the description there.
yeah, they should follow right there. I'm not too much personally on social media, but the Twitter, the Knackly Bang, go for that. That's a good way to follow us.
Awesome. Well, thanks again,
Awesome.
everyone. Hope you have a fantastic rest of your day.